Hey friends, I took all your suggestions and ignored all of them. I figured to start today, I'm just going to do a few more from the packet. There were some furrowed brows in class today, so what I'm going to do is I am going to go over and do numbers 5 and 12 on the back, that bottom one. Okay, I think they're going to be good for generating functions, looking at functions, and figuring out the discontinuities and stuff like that. But before we get started, okay, maybe this will open up the thing that I want. There we go. Remember, you might just need to, pause, rewind, rewatch, all that fun stuff. But definitely have your packet, notebook, calculator, pencil, whatever the materials you might need. Maybe challenge your friend to watch this as well and see if they understand it as well as you. I don't know, have some conversations. All right, I chose number 5. We're going to find the discontinuities. We're going to identify the vertical asymptotes and holes and all that stuff. But I chose this one because we need to do some factoring first. So pause the video and think about what those factors are going to look like. Your factors look just like mine. If they don't, then something's wrong and we need to practice our factoring because I'm awesome. Now, you'll notice, okay, we do have a common factor of x minus 2 top and bottom, so you know there is going to be a hole where x equals positive 2. Okay, you also know that since we have an x plus 2 in the denominator, we're going to have a vertical asymptote at x equals minus 2. Okay, now we just need to find the y value for the hole. Okay, so if I take that 2 and substitute that back in, we can evaluate r of 2. Okay, so we've got 2 plus 5 divided by whatever 2 times 2 plus 2 is. Okay, and that is going to give us 7. Scratch that. That's going to give us 5. I got ahead of myself there. That's really 3. Okay, so that means our hole will be located at 2 comma 5 eighths. All right, let's jump down and look at number 12, and then we'll call it a day. So with number 12, we're looking to write a function that satisfies all these fun conditions. So we are going to have a hole located where x equals 2 and x equals 5. We're going to have a vertical asymptote at x equals 0. And we need to have a 0, a root, an x-intercept where x equals 1. Okay, so let's do the easy stuff first. Okay, so h of x equals, now let's think about this. We need to have a hole where x equals 2 and x equals 5. Okay, so that means we need to have an x minus 2 and an x minus 5 in both top and bottom. Those are going to simplify to 1. They're going to cancel out, and we will be left with whatever else we have. Okay, now we need a vertical asymptote at 0, which means a value of 0 in the denominator will make it so our function's undefined, which means we've got an x. You can put it over there. You can put it over there. It is your choice. I think it's pretty more standard to put it up front. Now we need to have a 0 where x equals 1. Okay, so again, reminder for all these. Okay, take your factors, make them equal to 0, or take your solutions, make them equal to 0, and then you get your factors. So we know this function right here will do all those things that we've got going on there. Okay, but I think it would be good practice for us to, figure out exactly where everything is. Let's actually graph this. Okay, so pause the video, maybe see if you can figure out where everything goes, and then click play again, and we'll get that. While I was on pause, what I did is I put in my vertical asymptote. I don't know why Cami won't give me the arrows, but I got my vertical asymptote at x equals 0, and I plotted my y-intercept of x equals 1. Okay, now just for fun, okay, the limit, okay, as x goes out to negative infinity, so as our x values decrease without bound, okay, our function, okay, notice we got 3x's up top, 3x's down below. Divide the leading coefficients, which means our function is going to have a horizontal asymptote at x equals, or sorry, y equals 1. Okay. Now, then once we get this in here, I think it's going to be fairly obvious what this function is going to look like. However, we still are going to need to figure out the coordinates of the holes. Okay. So let's get this going. Again, asymptotes in red. All right, let's do this. So here's what we know. Okay. I know this. You know this. Everyone knows this. Okay, and we're going to be left with x minus 1 divided by x as our simplified function. Okay, so let's start calculating stuff. So again, here's our simplified h of x. We're going to evaluate h of 2. Okay, and also h of 5. Okay, and that'll give us the y coordinates of where those holes are going to be. So 2 minus 1 divided by 2 is 1/2. Okay, so somewhere over here at 2 comma 1/2, we're gonna have a hole. Okay, and then same thing, 5 minus 1 divided by 5 is 4/5. Okay, so at 5 comma 4/5, okay, there's going to be another hole over there. So let's draw in what we know. Okay, this has to come up like that, level off. Okay, it's going to look like that, which means up top over here, it's going to look something kind of like that as well. Okay, now let's take this a step further about, oh, that's not what I want. Okay, and then talk about some more recent stuff. So, all right, so we know, hang on if I can just pull this. Nope. Okay, the limit, actually, let's go down here. The limit as x approaches 0 from the negative side, okay, our function h of x goes up to infinity. Okay, but the limit as x approaches 0 from the positive side, okay, our function goes downward. I don't know if I can squeeze this in. No, it won't let me. I will write it over here. Okay, and now I'm going to just move that over there. It goes down to negative infinity, and now we have satisfied everything that I was hoping to do with that. Okay, so hopefully this helps. I know there were some furrowed brows in the conversation today, but we'll do more, and there'll be more videos to come. Have a great afternoon. Peace out, everyone.